In this little video, we're going to see an example for solving a simple differential equation. This example is taken from one of the exams over the last years, so that's a pretty typical exam problem, obviously. So here we go. The example is solve the following differential equation. And the differential equation is given as f of x plus 3f prime of x equals minus 2x. And we also have an initial value here. We want the solution with the property f of 0 equals 7. So let's first mention that this right-hand part here, this is the inhomogeneous part. That is the part that does not include f or one of its derivatives, so that's the inhomogeneity of this differential equation. So, as you know, we will start with the homogeneous part first. The homogeneous differential equation is f of x plus 3f prime of x equals 0. Or reformulated in the way that we did in the lecture, f prime of x equals minus 1 over 3 f of x. And in this formulation, we can write down the solution. So the solution here is f of x equals some constant gamma times e to the minus 1 over 3x. Okay, let's quickly check that just to make sure that we did this correctly and compute f prime. F prime of x is minus 1 over 3 times gamma times e to the minus x over 3. So if you substitute that in our differential equation, remember that was f of x plus 3f prime of x. That is then gamma times e to the minus x over 3 minus gamma times e to the minus x over 3. Then this is obviously 0. And that's precisely what we wanted. Okay, so we solved the homogeneous part. So this is a set of all possible solutions for the homogeneous differential equation. Now for step 2. We're going to determine one particular solution of the inhomogeneous system through variation of constant. So we're going to make the following ansatz. We're going to say, well, f of x, the homogeneous solution is gamma times e to the minus x over 3. So we just replace gamma by an unknown function c. And then we have c of x times e to the minus x over 3. So that's our ansatz. And we're going to substitute that into the differential equation. So we need to compute f prime. And f prime is c prime of x times e to the minus x over 3 minus c of x times 1 over 3 times e to the minus x over 3. Now remember our differential equation. That was f of x plus 3 f prime of x equals minus 2x. If we substitute that ansatz here into our differential equation, what we get is f, that is c of x times e to the minus x over 3, plus 3 times c prime of x e to the minus x over 3, minus c of x e to the minus x over 3 equals minus 2x. Now this part here, and this part here, those cancel out. So we are left with 3c prime of x e to the minus x over 3 equals minus 2x. And that means c prime of x equals minus 2 over 3 x times e to the x over 3. So we're going to need to solve that. And that means c of x is the integral of minus 2 over 3x e to the x over 3 dx, or minus 2 over 3 the integral of x times e to the x over 3 dx. You hopefully remember how to solve integrals of this kind. In this case, partial integration by parts seems a good choice. Remember the formula for integration by parts was integral of function u times v prime is the same as u times v minus the integral of u prime v. And in this case, we'll use x as u and e to the x over 3 as v prime. That will have the effect that in one step this x will diminish because x prime is just 1, and then we can compute the integral. Okay, so we have minus 2 over 3. We'll just keep that outside. Now using that formula, u is x, v prime is e to the x over 3, so we need to integrate that. And the integral of that is 3 times e to the x over 3. Because if you differentiate this 3 times e to the x over 3, then you get 3 times e to the x over 3 times 1/3, and 3 and 1/3, those just cancel out. Okay, so that's uv part, and then we have minus the integral of 1 times, and again, 3 e to the x over 3 dx. Okay, we're almost there. Minus 2/3 times 3, that's minus 2x e to the x over 3. And here we get a plus, and again 3 cancels out, so we have plus 2. And let's integrate that thing already. So we already did that. The integral of e to the x over 3, that is 3 e to the x over 3. Okay, so all together, what do we get? Well, basically this is e to the x over 3. And here we have a minus 2x plus 6. So that's our function c. Remember, right? That is the function c of x. So that means our particular solution f of x is then c of x times e to the minus x over 3. So f of x is this function here, e to the x over 3 times minus 2x plus 6 times e to the minus x over 3. And you can see the e part actually cancels out. So we're left with minus 2x plus 6. That is a particular solution of the system. Let's verify that quickly. Remember, that is the differential equation. F of x plus 3f prime of x equals minus 2x. Well, now if we do the computations here, we have minus 2x plus 6, that's the f part, plus 3 times, well, the f prime part is just minus 2. And that is minus 2x plus 6 minus 6, that is minus 2x. And that's precisely what we need. Okay, so that is actually one particular solution. So, third step. Set of all solutions. How does that look like? Well, we take this one particular solution and we add the set of all homogeneous solutions to that. Okay, so the set of all solutions is f of x is minus 2x plus 6 plus constant gamma times e to the minus x over 3. So that's our set of solutions here. And finally, we're going to use our initial value. Remember, that was f of 0 needed to be 7. So we just substitute that into the equation. F of 0 is 6 plus gamma times e to the 0. So 6 plus gamma. And if that is going to be equal to 7, then that means gamma needs to be 1. So our solution eventually is f of x equals minus 2x plus 6 plus e to the minus x over 3. And that satisfies all the conditions that we want. Okay, this solves our initial value problem. Okay, that concludes the example. Thank you for your attention.